Metalworking transforms raw materials like aluminum and copper into powerful industrial components, fueling innovation, precision, and strength across global industries. The 700 kilograms copper melting furnace is a specialized industrial unit designed for efficiently melting and refining copper and its alloys. With a melting capacity of up to 700 kilograms per batch, it is widely used in foundries, metalworking workshops, and non-ferrous casting facilities. The furnace is typically equipped with an advanced heating system, either induction or fuel-fired, ensuring rapid temperature rise, precise thermal control, and uniform heat distribution. This guarantees that the molten copper achieves the required purity and fluidity for subsequent casting or forming processes. Constructed with durable refractory linings, the furnace is capable of withstanding extremely high operating temperatures while maintaining safety and energy efficiency. Its robust design also allows for long-term performance with minimal maintenance. In addition, modern versions often include automated tilting or pouring mechanisms, reducing manual labor and improving workplace safety. Overall, the 700 kilograms copper melting furnace is a reliable and versatile piece of equipment, essential for industries producing electrical components, machinery parts, art castings, and other copper-based products. After the aluminum slab is withdrawn from the furnace, it is immediately placed on the roller table leading to the hot rolling mill. At this stage, the slab has reached the necessary ductility, making it suitable for undergoing significant thickness reduction. The slab is then guided toward the roughing mill, where the initial deformation process begins. In the roughing mill, the slab is repeatedly passed back and forth between massive, powerful rolls. Each pass reduces its thickness in a controlled manner, while simultaneously elongating the piece into a wider and longer plate. The mechanical action of the rolls is carefully synchronized to ensure a uniform reduction across the entire surface. To assist in this stage, high-pressure water sprays are applied directly onto the slab. These jets remove any scale or oxide particles that may have formed during the heating phase, leaving the surface clean for further rolling. Maintaining a clean surface is critical, as residual scale could be pressed into the metal, causing surface defects or inclusions. The roughing process continues until the slab is transformed into a much thinner and elongated strip. During each pass through the roughing mill, adjustments are made to roll gaps and pressure levels. Operators and automated control systems monitor parameters such as temperature, speed, and reduction ratio to guarantee consistency. The aim is to reach an intermediate thickness that prepares the strip for the next stage, while also refining its shape and surface quality. Once the required intermediate thickness is achieved, the strip is transferred seamlessly to the continuous rolling mill. The continuous mill, also called the finishing mill, receives the elongated strip directly from the roughing line. In this stage, the strip undergoes further reduction as it passes sequentially through a series of closely spaced roll stands. Each stand exerts additional pressure, steadily bringing the strip closer to its final thickness. Unlike rough rolling, where thickness reduction is relatively large per pass, continuous rolling involves smaller, more precise reductions that accumulate across many stages. Throughout this process, the strip moves at increasingly higher speeds. As thickness decreases, rolling velocity is adjusted upward to maintain steady material flow. Sophisticated automation systems coordinate the operation of each stand, ensuring smooth transition of the strip from one roll set to the next. The alignment of the strip is constantly monitored to prevent misfeeds or edge cracking. Another critical aspect of continuous rolling is maintaining dimensional accuracy. Sensors and measuring devices continuously check strip thickness, flatness, and profile. When deviations are detected, corrective actions are automatically applied by adjusting roll pressure, tension control, or cooling intensity. Such real-time monitoring guarantees that the final product meets strict industrial specifications. Once the desired final thickness and mechanical properties are reached, the strip exits the last rolling stand. At this point, it has become a long, thin, and flexible band of aluminum. Instead of being cut immediately, it is directed toward the coiling system. Here, the strip is wound into a large coil for ease of handling, storage, and transportation. This initial coiling marks the completion of the hot rolling stage. The coil produced after continuous rolling is not yet the final product, but serves as the starting material for subsequent processes such as cold rolling, annealing, or surface finishing. However, the hot rolling stage is crucial, as it establishes the basic geometry, strength, and internal structure of the aluminum strip. Through this coordinated sequence of rough rolling, continuous rolling, and coiling, the aluminum slab is successfully transformed into a thin strip with controlled thickness, uniform structure, and a clean surface, ready for the next stages of production. The Schuler X250 aluminium extrusion press represents advanced technology in the production of collapsible aluminium tubes. Designed to combine power with precision, this press demonstrates how modern extrusion can efficiently transform billets into seamless tubes of high quality. It is widely recognized for its capability to handle tubes with diameters ranging from approximately 10 mm up to 25 mm, providing flexibility for different industrial applications. The operation of the press is simplified to the point that it can be controlled by a single operator. Through the central control panel, the operator monitors every stage of the extrusion cycle, including billet heating, die positioning, extrusion force, and the quality of the tubes being formed. Typically, billets are heated to temperatures around 300 to 315 degrees Celsius before extrusion begins. Once aligned, the press operates smoothly, pushing the billet through the die to create uniform collapsible tubes. One of the key advantages of the machine is its consistent performance and reliability. The press has already demonstrated the ability to produce thousands of tubes under testing conditions, all meeting technical standards without requiring additional welding or finishing. Each tube is carefully reviewed for dimensional accuracy, shoulder formation, and membrane thickness. By combining automation, precision engineering, and user-friendly operation, it ensures both productivity and product quality in aluminum tube extrusion. The Envoy Bronze Foundry has established itself as a forward-looking facility by integrating green Furan technology into its casting operations. This modern resin system represents a significant improvement in the foundry industry, especially in terms of environmental performance and working conditions. Traditionally, Furan binders have been widely used in sand casting due to their excellent strength and dimensional accuracy. However, one of the major drawbacks of conventional Furan systems has always been the unpleasant odor and excessive smoke released during pouring. Envoy's adoption of green Furan directly addresses these concerns, creating a cleaner, safer, and more sustainable workplace. When molten bronze is poured into molds prepared with green Furan, the amount of visible vapor generated is noticeably reduced compared to traditional systems. This means the casting floor no longer fills with dense fumes that obscure visibility and create discomfort for workers. More importantly, the distinct chemical smell normally associated with Furan resins is drastically minimized. Employees and visitors immediately notice this difference, as the working atmosphere feels less harsh and significantly more breathable. This improvement not only benefits worker health, but also demonstrates the company's commitment to cleaner industrial practices. Beyond the reduction of fumes and odors, green Furan also maintains the essential technical qualities required for high-quality bronze casting. The system provides excellent bonding strength between the sand grains, resulting in molds that can withstand the high temperatures and pressures of molten metal without deformation. This ensures that castings achieve precise dimensions, fine surface finishes, and minimal defects. Envoy therefore gains both environmental and technical advantages without compromising on production quality or efficiency. Another important aspect of green Furan technology is its contribution to sustainability. By lowering the emission of harmful compounds during casting, it helps the foundry comply with stricter environmental regulations, while also reducing the need for expensive air extraction and filtration systems. This eco-friendly binder system aligns with global trends in responsible manufacturing, where industries are increasingly expected to adopt processes that minimize environmental impact. For Envoy, the decision to use green Furan reflects not only technological innovation, but also a corporate philosophy of environmental responsibility. The practical benefits extend even further. A foundry using green Furan experiences less residue buildup in its molding equipment, making maintenance easier and more cost-effective. In addition, the improved working atmosphere contributes to higher employee satisfaction and productivity. Workers feel more comfortable and motivated when they are not exposed to strong odors or thick smoke. Visitors, clients, and partners who tour the facility also recognize these improvements, strengthening Envoy's reputation as a modern, clean, and advanced foundry. In conclusion, Envoy's bronze casting workshop demonstrates how the integration of green Furan technology can transform traditional foundry operations. By greatly reducing the fumes and unpleasant smells associated with Furan binders, the system creates a healthier work environment and supports sustainable production practices. At the same time, It delivers the high-performance characteristics necessary for producing accurate, durable, and aesthetically pleasing bronze castings. Envoy's adoption of this innovative binder system highlights its commitment to innovation, environmental care, and the well-being of its workforce, setting a strong example for the wider foundry industry. The automatic double-end aluminum tube beveling and flat-end machine is designed for efficient processing of short aluminum tubes or steel bars. It simultaneously bevels and flattens both ends with high precision, ensuring consistent results. Featuring a dual-head design, the machine greatly enhances productivity, while its integrated high-speed automatic feeding system is optimized for handling short materials. Versatile in application, it can process a wide range of materials, including steel, stainless steel, copper, and aluminum, making it suitable for diverse industrial requirements. The production of large electric motors involves a series of meticulous steps to ensure durability and performance. The process begins with rewinding and servicing both AC and DC motors of various sizes, where damaged windings are removed and replaced to restore efficiency. Next, random winding of a multiple-strand stator coil is carried out. This step involves winding insulated wires into the stator slots in a non-layered, randomized pattern, ensuring compactness and even distribution of current flow. Following this, layer winding is applied to a rotating field coil. In this process, coils are wound in precise, organized layers, providing a balanced magnetic field that enhances the motor's stability. Random winding is also performed for a rotating exciter rotor, where wires are arranged in a randomized yet controlled fashion to energize the exciter system. In some cases, lamination replacement is necessary, as seen in a 500 kilowatts generator. Old or damaged laminations are removed and replaced with new ones to reduce core losses and improve efficiency. Preparation to rewind a DC armature follows. The armature is cleaned, inspected, and insulated before new coils are wound around its slots. Layer-wound pole pieces are then reassembled with rectangular wire for a 5,000 kilowatts generator, ensuring mechanical strength and improved heat dissipation. Connections are made on a main DC Fields motor generator set, carefully soldering and insulating terminals to ensure safe current flow. Wedging a newly rewound stator comes next. Insulating wedges are inserted into stator slots to secure coils firmly in place, preventing vibration and abrasion during motor operation. The process of inserting coils in a large random wound stator is one of the most critical stages. Coils, previously prepared and insulated, are carefully positioned into the stator slots using specialized tools. Each insertion must be precise to avoid damaging the insulation or causing short circuits. Spacers and insulating materials are placed between coils to maintain electrical clearance and mechanical stability. Because of the stator's size, this step requires significant manual skill combined with mechanical aids to ensure all coils are evenly distributed. Once fully inserted, the coils are tied and supported to withstand high operational stresses. Finally, banding the rotor is performed to secure the windings tightly around the rotor core. High-strength bands, often made of fiberglass or steel, are applied under controlled tension to prevent coil movement caused by centrifugal force during high-speed operation. The banding process ensures that the windings remain intact under extreme loads and temperatures. Multiple layers of banding may be applied depending on the rotor design. Afterward, the rotor undergoes balancing to eliminate vibration, completing the manufacturing process of the large electric motor. The Ras Al Khair complex is a major industrial hub in Saudi Arabia, designed to integrate energy, water, and heavy industry in one strategic location. At its core, the complex includes a large-scale power plant and a seawater desalination facility, which together provide both electricity and fresh water for industrial operations and the surrounding area. A key component of the complex is the alumina refinery, which relies on a portion of the generated power and water supply to ensure efficient production. This close integration highlights the complex's role in supporting the aluminum industry while maximizing resource efficiency. By combining power generation, water desalination, and alumina refining, Ras Al Khair stands as a symbol of advanced industrial planning in the kingdom. The Raya Magnet Wire Guildford facility in Connecticut produces bare and insulated magnet wires in copper, aluminum, and alloys, shaped round, square, or rectangular. As one of 5 U.S. plants, it is ISO 14001 certified, emphasizing safety, sustainability, and environmental responsibility. The making of an ORI pillar requires both precision and consistency, as these small but essential parts serve as the vertical supports that hold the plates of a gearwork frame together. In this process, 1/4-inch brass bar stock is carefully selected for its durability, workability, and attractive finish. The brass bar is mounted on a lathe, and a follower rest is employed to provide steady support during turning. This tool is particularly useful when producing long, slender pieces, as it prevents bending, vibration, or deflection under cutting forces. The operator turns the stock to the desired diameter, shaping smooth and uniform surfaces that ensure the pillars fit perfectly within the orrery's framework. By maintaining accuracy, multiple identical pillars can be produced from a single length of brass bar. Once cut to length, the pillars are polished to enhance their appearance and prepared for final assembly. Though small in scale, these components are vital to the stability and alignment of the mechanical model, allowing the orrery to function smoothly and display celestial motions with elegance and reliability. The adoption of automated green sand molding systems has become an important development in the modern foundry industry in Vietnam. Until now, many foundries across the country have invested in such technology to improve both consistency and productivity. These systems are designed to automatically prepare and mold fresh sand, ensuring that the production of castings meets strict requirements for dimensional accuracy and surface finish. To support the coating and pouring process, Inductotherm has introduced an innovative chain coating system, particularly suitable for medium-speed operations with a working capacity below 200 to 250 molds per hour. This solution allows for precise synchronization between mold preparation and metal pouring, ensuring that each mold is processed at the correct speed and in the exact position. By controlling the sequence in this way, the system minimizes errors, reduces metal wastage, and improves overall casting quality. One of the key advantages of the system is its ability to adapt to molds of different sizes, depending on the specific product and casting requirements. Flexibility is essential in foundry operations, where a wide variety of components may be produced, from small mechanical parts to larger, more complex castings. The chain coating system ensures that regardless of the mold's dimensions, the process remains accurate and reliable. In addition, the system incorporates advanced position-determining technology. This feature guarantees that every mold is identified and aligned correctly before the pouring operation begins. As a result, the molten metal is directed into the mold cavity with precision, reducing the risk of misalignment, defects, or unnecessary rework. Overall, the automated green sand molding system with Inductotherm's chain coating offers Vietnamese foundries an effective solution that combines efficiency, accuracy, and adaptability, aligning with the industry's move toward modernization and sustainable production. The Ria Magnet Wire Fort Wayne plant is a world-class manufacturing facility with a long history of innovation and growth. It produces magnet wire and winding wire in every size and shape, from bare copper to advanced continuously transposed cable, as well as enameled, taped, and Dacron glass-covered wire. The plant manufactures over 500 custom products annually, each designed to exceed customer standards. Starting with high-quality copper rod, wire is processed through extrusion or rolling, then fabricated through enameling, wrapping, or taping. The site also houses a transformer center of excellence with cleanroom facilities and rigorous quality monitoring. The Schleuniger Unistrip 2550 is a fully programmable wire stripping machine designed to deliver precision, versatility, and efficiency in modern wire processing. It is built to handle a wide range of applications, taking productivity and reliability to a new level in the field of cable preparation. This advanced benchtop solution supports both full and partial stripping, allowing manufacturers to meet diverse production requirements with one compact unit. One of the machine's key strengths lies in its ability to process with interchangeable blade sets. Operators can easily switch between die blades, flat blades, multiple radius blades, or contour blades, enabling them to tackle a variety of wire types and shapes. With these options, even flat materials can be processed with high consistency, greatly expanding the range of possible applications. The Unistrip 2550 also integrates unique functions such as recut, regrip, and multi-strip operations, providing flexibility for complex production needs. Strip lengths up to 43 mm 1.7 are supported, making it suitable for both short and long precision cuts. Ease of use is a central feature of this machine. Its color touchscreen interface allows operators to quickly select wire sizes from a pre-programmed library or create customized settings as needed. Adjustments to strip lengths, pull-off values, and other processing parameters can be made directly on the screen, The extended wire programming function enables the storage of up to 1,000 wire programs, which can be recalled instantly to reduce downtime. Optional barcode scanning further improves efficiency by minimizing the risk of loading incorrect programs. The Unistrip 2550 ensures smooth operation with software-guided blade changes and quick-change gripper jaws. These features not only simplify setup, but also help maintain consistent performance across production runs. Backup of stored wire programs via USB provides additional security and convenience, while networking capability supports integration into broader manufacturing systems. For operators, the machine offers a user-friendly and ergonomic working environment. The illuminated work area improves visibility during processing, and multiple language support enhances accessibility for global users. The highly responsive trigger sensor automatically adjusts according to the selected wire size, enabling precise handling of small and flexible wires with minimal operator input. In terms of performance, the Unistrip 2550 delivers repeatable, highly accurate results. Its mechanical precision, combined with short cycle times, translates into significant improvements in productivity and process reliability. By maintaining consistency across large production batches, the machine reduces material waste and increases overall throughput. Altogether, the Schleuniger Unistrip 2550 is more than just a stripping machine. It is a comprehensive, programmable solution that adapts to the demands of modern wire processing. With its robust features, intuitive interface, and reliable performance, it sets a new standard for benchtop wire stripping technology, offering manufacturers both flexibility and confidence in their operations.